value, okay, of the voltage on top of the charge. You see that as I move the voltage box closer and closer to the charge, okay, the reading becomes more and more negative, more and more negative. Okay, in magnitude it becomes larger and larger. So in absolute value, we get a larger and larger voltage. See that? Larger, I'm at 172 in absolute value. Okay, 200, 344. Okay, so 770. So what is the maximum value possible? That's what the question is asking you. Okay. Yesterday when I tried this, I got even higher than 770. Okay, so play with this and try to determine what the maximum value will be. Okay. So now we need to measure a distance of 3 meters. Okay. So 3 meters here, I'm at 243 centimeters, so that's 2 meters and 43 centimeters. So 3 meters will be 300 centimeters. So let's see, where is that? About here. Yeah, so that's 3 meters. Okay, and to help me out, I can also use a grid. Okay, so this is about 3 meters. So maybe if I put the charge here at a corner on the grid. Okay, so hold on. Let me move the charge. Let me move the charge towards a corner about here. Alright, so this seems to be a corner. Now I should find 3 meters more easily. Okay, let me see. So on top of the charge, so that means at the center of the circle, representing the charge. So about here, and 3 meters should be yeah. Okay. Okay, about. Okay, sorry. Yeah, about here. So this is 3 meters. All right. So now we need to so 3 meters away. So drag the tape across and measure the distance of 3 meters away from the center of your point charge. We just did that. Now gather data from the simulation for radial distance and associated voltage using your grid and the equipotential meter respectively. So at 3 meters we have a voltage of, I'm reading minus 2.998 volts. Okay. So you can so another 3 meters. This is another 3 meters. Yeah, are we going to get the same value? Let's move the voltage box there. About the same value, right? Okay, and so on and so forth. Okay, and then you can change also the distance to, so like 1.83. See, 1.83. What voltage do you get? I'm getting minus 4.887. And how about 1 meter and 11 centimeters? What voltage do you get? So move the voltage probe box there. Crosshairs on top of the orange cross, and I'm reading minus 8.009 volts. Okay, so it's as simple as that. And then you have to prepare an Excel spreadsheet recording all these values, and then find a graph and find the best fit relationship. So basically you have to determine the relationship there exists between the distance so distance away from the charge, and the voltage. Is there any relationship between the two? Okay, of course there has to be one. What kind of relationship is it? Okay, is it a quadratic relationship? Is it a linear relationship? Is it logarithmic? The function that relates the two? Is it exponential? Okay, so you have to find that out yourselves. Okay, so use Excel to make a graph and find the best fit relationship. Now, so that's relationship between distance and the voltage, or the electric potential in this case. Okay, the electric potential. Now we need to study the relationship between the electric field and the electric potential. Okay, so okay, so now we need to draw equipotential curves that have an equal potential difference between them. All right, that's the delta V described in the instructions page, the Word file that I posted on a Blackboard. Okay, how does their spacing relate to the E field? Okay, so we start with the positive point charge. So let me remove the negative point charge, the blue one, and replace it with the red one. Okay, let's take the red one, put it in the middle, just like we did before. Okay, maybe let me remove the meter stick for now. So there. Okay, so I have to draw the curves. Okay. Okay, so I'll put a curve maybe here. So to do that, I have to press the pencil, and I have an equipotential there. Okay, it's called equipotential because the electric potential is the same everywhere as you move around the circle. For every point on the circle, so you see that the potential is the same. Okay, I'm not doing it carefully, but you can check that out by going more slowly and seeing that the electric potential is going to be the same. Okay, it's going to be the same everywhere on the curve, which is green here on my screen, green curve. Okay, so you can decide what do you want the potential difference to be. Here I'm at the minus 30, maybe, I don't know, 10 maybe. Okay, let's say 10. Okay, let me read the instructions. So, so first explore by placing the 1 nanocoulomb positive point charge. So we just did that in the middle of the screen. Move the voltage probe box to different locations near the charge and click plot. So we just did that to in just one location. Okay, so let me do that for another curve. So let's decide, let's say 10. So if it's 10, so this is 20, okay? It's kind of hard to make it exactly 20, but I'm just showing you how, so you can try to get as close to 20 as possible, okay? I've decided for a potential difference of 10, but it doesn't have to be 10. Okay, you can make it 5, you can make it 15, you can make it 20, 25, whatever value you want. But I want 10. So 10, since we already have a potential of 20, a electric potential of 20. So if I want a delta V of of 10, the next one has to be 20. Okay. Maybe 20 is a bit because then after 20 I will get 10 and then 0. So I will have only 3 curves. So maybe 20 is not a good choice. So maybe let's say so 3, I would have 10 curves. Okay, 3. Then I need 27. So where's 27 gonna be? It has to be close. It's kind of hard, isn't it? Okay, let's call this 26. Okay, so 4. Let me make delta V 4. Then I'll draw another one. You see, that's how it's done by clicking on the pencil. So 26 minus 4, that's 22. So let me see, where is 22 gonna be? Okay, so let me call this 22. Where's the pencil? What can I do? If I press the eraser, I'm going to erase everything. Okay, so maybe okay, let me call this 22. 22 minus 4 is 18. So let me find 18. 18 is about this, so this is 18. Press on the pencil, and I have another equipotential curve. Okay, minus 4, I get 14. 14 is here. Maybe a little bit farther away. Yeah, this is 14. Press the pencil. I have another equipotential curve. 14 minus 4, I get 10. About here. Press the pencil. I get there. Okay. I hope everybody's